In section 12.3, we're looking at surface area again, but this time we need to come up with surface area of pyramids and cones. So talking a little bit about pyramids to start. Pyramids have any polygon for the base. Okay, here I have a pentagonal pyramid, pentagon for the base. Here I have a square pyramid because the base is a square. So any polygon can be the base shape. The lateral faces are all what shape though? For a pyramid, we have each of these lateral faces being a triangle, right? So we have triangles for lateral faces no matter what the base shape is. And of course, every pyramid has that common vertex at the top here. By the way, the number of lateral faces, like this is a pentagonal pyramid, so the number of lateral faces would be 5 because the base has 5 sides. In a square pyramid, we'd have 4 lateral faces, 4 triangles, because the base is a square with 4 sides. A little distinction here between height of a pyramid and slant height of a pyramid. Okay, and you're going to have to be careful knowing the difference there. What is height versus what is slant height? Now the height of a pyramid is measured from that vertex down to the base at a perpendicular. So straight up and down at a right angle to the middle of the base here. This is the actual height. Okay, actual H there. From the vertex straight down to the middle of the base at a right angle, there's your actual height. But if you think about it, if I'm trying to do surface area today, if I need the area of the triangles, the actual height doesn't necessarily help me. What you're looking for when you want the height of the triangles, and I'm trying to find the surface area and find the area of those triangles, is I want slant height. Slant height is perpendicular distance between the base and the vertex. So I'm going to each side at a right angle. So this would be slant height here. I'm basically the height of the triangle, okay, going at a right angle to that base. And here, again, from a vertex to the base at a right angle. By the way, slant height, use the letter L. Kind of weird, but it's like we use the L instead of the S there. But slant height is the height of the triangles, okay? It goes at a right angle to the actual edge of the base. And one more definition for a pyramid to be regular. First of all, there's a regular polygon for the base. It looks like this is a regular pentagon. All the sides would be congruent, all the angles would be congruent. But also the vertex is directly over the top of the center of the base. As I did here, the height goes right down to the center of the base at a right angle. Then it is a regular pyramid. Okay? And basically you're only going to be working with regular pyramids today. So in this example, I have a regular square pyramid. I know it's a square pyramid because the base is a square. And then I have 4 triangular lateral faces here. Regular square pyramid has a height of 12 feet. Okay, that means if it just said height, it did not say slant height. Height at 12 feet is this red line going at a right angle to the base. So this here is 12 feet. And it has a base edge length of 10 feet. Base edge length, so off of the bottom, basically, the edge is 10 feet in length. Find the area of each lateral face and the total surface area. Okay, area of each lateral face. So I'm going to put LA for lateral area. Now keep in mind, what is the lateral area? The lateral area is each of the triangles. Okay, lateral area is each triangle. And what's the area formula for a triangle? Wait, a triangle's area is 1/2 base times height, isn't it? Well, for each of these triangles, I do know the base actually, 1/2 of the base of each of these triangles would be 10, right? It was a square pyramid and the base edge length was 10. What's the height of those triangles? Now the height of the triangles is not 12, that's the height of the pyramid going at a right angle. What I want is the height of the actual triangles. So the slant height. Okay, this would actually be slant height of the pyramid. And I have to do some work to find that here. So I'm going to call this L for slant height. And what I'm going to do is form a right triangle. You're going to have to do this a few times today. Form a right triangle from the actual height. This would be actually half the base. Think about it. If this whole thing is 10, going all the way across would have been 10 for this Even though it's in the center of the square, it would still be 10 across, so this is half of that, or 5. Okay, now I can find the slant height because I have a right triangle here. I have the legs at 12 and 5. I can find the slant height. So to find that slant height, I'm going to do 12 squared plus 5 squared equals slant height squared. And let's see here. 12 squared plus 5 squared is 169 equals slant height squared. This is a nice one because I know that when I take the square root to get just slant height, 169 is a perfect square. Squared is 13. So there we go. My slant height is 13. And that's actually the height of these triangles. Each of the 4 lateral faces would have a slant height of 13. So that goes right in here. And now, what is the area of each triangle? A half times 10 times 13. Each triangle has an area of 65, and this was in feet, so area would be feet squared. So I did the first part. I found the area of each lateral face, each triangle. Okay, the lateral area of each of those faces, each of those triangles. There we go. But now I want total surface area. So what's the surface area of this entire pyramid? I honestly did all the hard work here. How many of these triangles do I have? Well, it's a square pyramid. The base has 4 sides. There are 4 triangles here. So I have 4 triangles for the lateral area portion of it. Plus, I have the square base. Plus the square for the base. Okay. Now, each of the triangles, it would be 4 times 65. We just figured that out a minute ago. Plus, what's the area of the base? Well, it's a square. And the square is dimensions of 10 by 10, which is obviously 100 there. And 4 times 65 is 260. Final surface area, 260 plus 100, 360, and it would be area, so feet squared, for total surface area. Okay, so for any pyramid, you're finding the area of the triangles. Decide how many you have. It's the same as the number of sides off the base. Add the area of the base to it, you got total surface area. And if they ask for just lateral faces, they want the area of each of those triangles. Again, make sure when you're talking about the height of the triangles, you're actually looking at slant height, not the physical height of the pyramid. Let's try another example, a little bit trickier here. Find the surface area of a regular octagonal pyramid. Okay, it is regular. Octagonal meaning this base is an octagon. If the slant height is 18 feet. That's nice that they gave that to us. Slant height is 18 feet. So that would be from a vertex, at a right angle to a base. That's the height of the actual triangles. That's awesome. So that's 18 feet. The apothem is 5.7 feet. The apothem, they're talking about, the base, the actual octagon down here. Now remember, apothem goes at a right angle to the side. I need that to come up with the area of that octagon, 5.7. And the sides of the base are 13 feet. So that would be sides of the octagon, 13 feet. Okay. Surface area of the entire pyramid. Let's think about what we're doing. First of all, we have the base. We're going to have to find the area of that octagon. Surface area of the base, which is this octagon here. Gonna need that. Then I'm going to have to add in all of the lateral area. Well, the lateral area, we have how many triangles? Well, if it's an octagon and there's 8 sides, there's 8 triangles for the lateral area. Okay, what's going to be the formula for the area of that base, the area of an octagon? Remember, any regular polygon, area is 1/2 ANS. Plus I have 8 triangles. It's going to be 8 times what's the area of one triangle. The area of a triangle formula is 1/2 base times height. Let's start plugging in what I know. That octagon, 1/2 ANS. Do I know A? Apothem? Yes, that was 5.7. Number of sides. It's an octagon, so 8. S is side length. Oh yeah, the side length of the octagon was 13. Thank goodness I had all of these things. plus, now I had 8 triangles, so it's 8 times 1/2 base times height. 8 times 1/2 is 4. What's the base of these triangles? Well, each of the triangles has its base along the sides of the octagon, and the octagon had sides of 13. And what's the height of those triangles? They did give us slant height, which is the height of the triangles, and that was 18. Whew. Now I'm ready to figure all this out here. I'm going to do 1/2 times 5.7 times 8 times 13. For that portion of it, I get 296.4 plus, and then I'll do 4 times 13 times 18. That gives me all the areas of all the triangles. The triangles are the lateral areas 936, and add those together. Here we go. Total surface area is 1,232.4 surface area. It was feet squared then. So we just practiced finding the surface area of another pyramid. Again, all of the triangles for the lateral area, we had 8 of them here because it was an octagon. And then we had to find the area of that base, that octagon as well, and add those together. Alright, then moving on. We also said we were doing surface area of a cone today, so let's come up with a formula. What is the formula for surface area of a cone? You notice I labeled the radius, and L, remember, is slant height. Let's do the easy part. What's the shape of the base of a cone? Base of a cone has to be a circle. And what's the formula for area of a circle? Area of a circle is pi r squared. So good, I've got the base all done. The hard part, and this is going to take some work. What's the area of the lateral face of a cone? Like, what's the area of this rounded surface here? Well, if I make a cut along the side of a cone, along the height of a cone, or slant height, and I unroll it, what shape do you have? You actually get a sector. What shape do you have? You get a sector. If you unroll a cone, you get this portion right here. And we'll do this in class as well. But this is the shape you get, because if you like pull these two sides till they meet, you would get a cone there. Now I have this dotted line here because I'm going to set up a nice proportion here to find the area of that sector. Because if I compared the area of the sector, which is the cone, to the area of the whole circle, that should be the same ratio as the arc length of just the sector compared to the arc length or the circumference of the entire circle. So let's set up a proportion. I'm trying to find the area of the sector, which is really the area of the lateral area of that cone. Okay, we're trying to find that. This is the unknown here. So I'm just going to call this x. We don't know the area of the sector. Now, if you were finding the area of this circle, the area of the entire circle would be, well, area of the circle is pi r squared, right? Except the radius of the circle is L. So this would be pi L squared equals, what's the arc length of the sector? Okay, actually go back to here. The arc length of the sector, this distance from here to here, came from the fact that it was originally around the bottom of the circle. So the arc length of that sector, the distance around this circle, is the same as the arc length here, and the distance around the circle is circumference. Circumference of the circle is 2 pi r, and r really is the radius there. Over circumference of this circle, though, circumference is 2 pi r, but the radius of this circle is L, remember, because I was coming from the slant height here. So this one is 2 pi L. And now to solve for x and to find this area of the sector, which is the lateral area of the cone, I need to cross multiply. But actually, before I cross multiply, do you notice that I can cancel out 2's and I can cancel out pi's here in this fraction? Now we'll cross multiply. So it's x times L, or slant height, equals, and then it's pi L squared times r. Actually, I'm going to do pi times r times L squared. And then, to get x alone, divide by L. Divide by L. And it looks like the area of the sector is pi r, just L, because L would cancel out the fact that it was L squared, and it would just be pi r L. Whew, so slant height, not slant height, excuse me, the lateral area, the area of this rounded surface of a cone is pi r L. So you add the circle, which is pi r squared, to pi r L, which is that lateral area, and you've got the surface area of a cone. Okay, you take the base plus the lateral area. The base was a circle, pi r squared, plus the lateral area, which was this rounded surface, which we came up with pi r L. Remember that L is slant height. And this is a formula you're going to use to come up with surface area of a cone. Let's try this out here. Surface area of this cone, what is it? Surface area is, do the area of this circle on the bottom, which is pi r squared, plus pi r L. This is the lateral area. Alright, do I know the area of the base, the circle on the bottom? Pi times the radius of that base. Radius is 10, cool. Pi times 10 squared plus pi times, what's the radius of that base? 10 again. What's the slant height? L is slant height. Ooh. Notice we don't have slant height, actually. Slant height would be this distance. Well, how am I going to find it? Well, this is definitely a right angle. Like 24 is the actual height of the cone. Okay, and I have the radius. They do meet at a right angle. Use Pythagorean theorem, of course, to find that L. So 24 squared plus 10 squared equals slant height squared. 24 squared plus 10 squared, I'm getting 676, equals slant height squared, undo squared by taking square root. And is that a perfect square? Yes, it is. Slant height is 26. Now I can put that in here. Slant height is 26 centimeters. And what is the surface area of my cone? I can just put this in my calculator right away, or I can simplify a little bit. 10 squared is 100, so this is 100 pi for that first term. 10 times 26, that would be 260 pi. 100 pi plus 260 pi would be 360 pi. And now I can go to my calculator. Again, you could just go to the calculator right away if you want a decimal. It's 1,130.97. Surface area, we got units as centimeters squared though, because we're talking about the area of all the surfaces here. So again, for surface area of a cone, just make sure that when you do pi r squared, using the area of the base, but especially when you do pi r L, you need the slant height. If you don't have it, you're going to have to use Pythagorean theorem to find that slant height. And last example today, a carpenter uses a weight in the shape of a right cone to identify vertical lines. This is called a plumb bob. The cone has a radius of 6.5 millimeters. So radius would actually be up here. A height of 13 millimeters. Height goes at a right angle to the base. Here it's vertex to base. This would be 13 millimeters for that height. Find the lateral area and the surface area. Now, I want you to keep in mind, what is the lateral area? That's just the pi r L portion of it. Okay? When you're doing lateral area, that's this area of this surface, not the base, not the circle. So lateral area would just be pi r L. When you do the surface area of the whole thing, then you are going to do the circle on the bottom. You are going to do pi r squared, the area of that base, plus the pi r L, which is your lateral area that you should find right up here. Keep in mind, L is slant height, and you don't have slant height. You're going to have to find that using Pythagorean theorem, of course, because these meet at a right angle. And I'm going to let you finish this for tomorrow. Come in with this one done, and we'll talk about it. Today, surface area of pyramids and cones. We got a formula for cones, but pyramids, remember, you just find the area of the base, whatever shape it is, and add the area of those triangles. Those are the lateral faces. Make sure you have slant height for the actual height of those triangles.